Hello everyone, so for today's video, I am going to discuss about the memory management. So we will explore how a computer handles memory and how programs are stored and why proper memory management is essential for a system performance. So, what is memory management? It controls and organizes a computer main memory, ensuring that the OS and application get the memory they need to run efficiently. We have here an example. So, this diagram shows how operating system will work. So, OS can be referred to as interface between the system and the user, or the interface between the hardware and the user. The basic goal of the operating system is to make efficient and convenient to the user. And the computer system, it consists of mainly two parts, which is the processor and memory. Now suppose the user is having a requirement. He need to solve a problem. So what he should do? He would write a program for it. Now the basic task operating system is to make the system or the hardware execute this program to the user and provide him a solution. For types of memory, we have the primary versus secondary memory. In computers, memory is divided into primary and secondary storage. Primary memory includes RAM, which is fast, but temporarily it loses data when power is off. ROM is also primary memory but contains permanent instructions. For the secondary memory, like hard drives and SSDs, it stores data for long term. Memory management helps determine how programs move between these two types during execution. Next is the memory allocation. So memory allocation refers to how memory is assigned to our programs. There are two main types of memory allocation. So we have the static allocation and the dynamic allocation. So for the static allocation, memory assigns before program execution, while the dynamic allocation, memory assigns while the program runs. So memory is divided into two main regions: the stack, used for local variables, and the heap, used for dynamic memory. Efficient allocation ensures smoother performance. Paging is a memory management technique where physical memory is divided into fixed size blocks called pages. This method helps eliminate external fragmentation. Programs do not need to be stored in continuous blocks, making memory use more efficient. Paging is also used in virtual memory, allowing systems to run large applications. So, what is segmentation? Segmentation divides memory based on a logical sections, like functions, data, or code modules. Unlike paging, segment size can vary. Segmentation is more aligned with the logical structure of a program, making it easier to manage and faster to access certain parts of a memory. So, virtual memory allows a computer to compensate for limited physical RAM by using part of the storage drive as additional memory. This enables multitasking and lets large programs run even if RAM is not enough. Although slower than physical memory, it greatly increases flexibility and system stability. So, what is memory fragmentation? Memory fragmentation occurs when memory space becomes divided into small unused gaps. There are two types of memory fragmentation. We have the external and the internal. So, for the external, its free memory is scattered. For the internal, it assigns memory is larger than needed. Techniques like paging, segmentation, and memory compaction help reduce fragmentation and improve memory use.